let's now go through this example here, which says state a possible Hamiltonian path and cycle for the graphs below. Now, what makes finding Hamiltonian paths and cycles just a little bit trickier than when we were dealing with, if we scroll up here, the Eulerian trail and Euler circuit, so the Euler trail and Euler circuit. Remember, for the Euler trail and Euler circuit, the first thing that we did is we counted up the degree of each vertex, and then from that we were able to determine whether or not it should be an Euler trail or an Euler circuit. Now, when we're dealing with Hamiltonian paths and cycles and trying to determine, if they exist, you can only do it by trial and error, so like inspection. There is no real technique to it. You've just kind of got to start drawing and see if it works. So you don't count up the degrees of each vertex, just kind of go for it and see what happens. So let's go for it. So if I'm dealing with a path, remember the characteristics of a path. I need to hit each vertex only once, and that's it. I don't have to use all the edges. I just need to hit every vertex only once. That's what it says here. No repeated edges. You don't have to use every edge. Every vertex exactly once, and you have to start and finish at different vertices as well. So what can we do here? We can go A to B, B to E, E to D, D to C, E to F. And we're done. That's the path. We're starting and ending at different points. We don't have to use every edge. We have to hit every vertex only once, and we've done all of those things. So A, B, E, D, C, F. A, B, E, D, C, F. All right, let's rub that out. And now we're going to ask ourselves the question, does a cycle possible for this graph here? Is a cycle possible? And again, you kind of just need to do trial and error, but hopefully just by looking at it, you can kind of see it's not going to work. Because remember, for a cycle, I need to end up at the vertex that I started with. So if I start at E, and I go, all right, E, D, D, C, now I need to go to F. Now there's no way of me coming back without repeating an edge, and I can't repeat an edge. So you might say, all right, what if I start at F? And I go F, C, C, D, D, B, B, E, E. I've hit a vertex twice. I can't hit a vertex twice. I can only hit it once. So that means, there's just no way of doing this. It's not possible. Perfect. All right, I'll stop here and I'll go through the next one.